Hi, this is a quick lesson on factoring using difference of squares. So difference of squares can always be factored using this. So when you have something squared minus something else squared, you can always write it like that quantity minus the other quantity times that quantity plus the other quantity. The easy way to see if this is actually true is if you FOIL this, you're going to get a times a, which is a squared, a times b is ab, negative b times a is minus ab, and negative b times b is minus b squared. These two terms cancel and you can see it's correct. So y squared minus 16. We need to make sure you can write it as one quantity squared minus another quantity squared. So y squared minus 4 squared. So this is our a, this is our b. We can write as y minus 4 times y plus 4. Okay. This is very easy as long as you can recognize two squared quantities. M squared minus 144. Obviously we have squared here. 144 is 12 squared. So that's going to be m minus 12 times m plus 12. 256 minus k squared. 256 is 16 squared. And obviously we have k squared. Something squared minus something else squared. 16 minus k times 16 plus k. Right. Now we're getting into something where you need to be a little careful. So 4b squared minus 81. Well, obviously we have b squared. What about the 4? Well, the only way to handle this correctly is if you write it as 2b quantity squared, which is actually 4b squared. But you need to have a single quantity that is squared here, not like that. 81 is 9 squared. So after this is done, you can see that it's 2b minus 9 times 2b plus 9. That's 9. Came out a little ugly. So now that you saw that, I hope this makes it a little bit easier to understand for this problem. 49 is a perfect square, so is 64. So you can rewrite that as 7p quantity squared minus, this is 8 squared, so 8q squared. Remember, single quantity squared, single quantity squared. So this is going to be 7p minus 8q times 7p plus 8q. Remember, every single one of these answers can be verified by foiling. You can foil it to verify that you are getting exactly the same thing. So this is our answer here, this is our answer here. Okay. There's one problem that I want to show you where you have a situation when you can extend it further. So you want to see something squared minus something else squared. So 16 is 4 squared. H squared, if you write it like this, you can see that it's 4 squared, which is 16. H squared squared will give you h to the 4th. Minus 625 is 25 squared. So I can write that as 4h squared minus 25 times 4h squared plus 25. So this is the sum, but take a look at this one. Let me write this on the side here. 4h squared minus 25 is actually also difference of squares. I can write 4h squared as 2h quantity squared, and 25 can be written as 5 squared, which is going to become in turn 2h minus 5 times 2h plus 5. So to completely factor that, we need to take this and put it here. So complete factorization here is 2h minus 5 times 2h plus 5 times 4h squared plus 25. And this one is the completely factored expression. And I hope this helps.